All right, we're gonna continue with the trig stuff. All right, so trigonometry. We kind of introduced this the other day, but we're going to get it a little bit more specific this time. All right. Now, when we do this trigonometry stuff, we are doing things called trig functions. I'll write that down too. So trigonometry. Don't talk. I'm talking. So trigonometry is the main subject, but the specific things we're talking about today, and we started mentioning a little bit the other day, are called trig functions. There's 3 basic ones. There's actually 6 altogether. We're only going to talk about 3 of them. And do you remember what they are? Sine, right? Cosine, and tangent. Good. These 3 words just represent a ratio between 2 sides of a right triangle. Notice what I said. 2 sides of a what? Of a right triangle. So this only works with what kind of triangles? With right triangles. Okay, that only works with right triangles. It does not work with a non-right triangle. So if you don't have a 90-degree angle in here, this stuff will not work. Everybody understand that? All right, a lot of people have a hard time understanding that because they try, even in my honors classes, I was looking at some of the quizzes and tests, people are trying to do this trig functions with a non-right triangle. You can't do it with an obtuse triangle. You can't do it with an acute triangle. You can only do sine, cosine, and tangent with what? A right triangle. Hopefully you heard that. All right, here we go. These words represent a ratio between 2 of the sides of our right triangle. Okay, the sine represents, and we shorthand it by using S-I-N. We don't say sin, but we say sine. Okay, even though it looks like this. Go ahead, Isaiah. What is it? It's the opposite. I'll write down like this, over the hypotenuse. That's right. So the sine is the opposite over the hypotenuse. For instance, if I called this letter A right here, this is angle A. So this side, this would be the opposite side, and this would be the hypotenuse, wouldn't it? What would this side down here on the bottom be to angle A? Right. Now notice what I said. Listen, I'm very careful with how I'm saying this. I said, what would this side be in relationship to angle A? It would be adjacent. What if this was angle B up here? Would this be adjacent to angle B? No, it would be what? It would be opposite of angle B, and this would be what? Adjacent to angle B. What about the hypotenuse? Does that change? No, because the hypotenuse is always what? Opposite. Adjacent means next to. All right? So people use that in conversation actually a lot. You wouldn't believe it. Not too many students probably say it, but if you hear an adult, listen to me. If you hear an adult, I mean, I teach this all the time, and I tell my kids to keep your ears open and, listen for that word. So like on TV or people in conversation and things like that, I hear people say adjacent quite a bit. So if you keep your ears open, you'll hear people talk about that. You'll say, oh, well, the school is adjacent to this neighborhood, or I live adjacent to this store, or whatever the case is. All right, people will say that. Students don't say that very often, but as you get older and your vocabulary increases, people will say adjacent instead of next to. All right. Here's another thing that bothered me a little bit when Mrs. Bove talked to me. And again, I don't know who. She didn't give me names. I have no idea. It's just someone who went in the resource room. So listen. Don't talk. She told me that several people, she didn't tell me who, but several people didn't even know that the hypotenuse was opposite the right angle. That bothered me to no end. I couldn't believe that people that have been sitting in my class all year did not understand that the hypotenuse is opposite the right angle. We've talked about that many, many, many times. Have we not? Yeah. We have. Okay, so the hypotenuse is opposite the right angle. See how it's across from it? See, it's across from it. It's not next to it. See, this one's next to it. This one's next to it. You see it? This one is across from it. It's opposite. See how they're opposite each other? The hypotenuse is always opposite the right angle. I hope you guys are paying attention. This is opposite angle A. This side down here is opposite angle B. Hypotenuse is opposite the right angle. Are you with me with opposite? Okay, because look, the hypotenuse doesn't share either one of the 2 sides that make up that angle, does it? So it's the one side that doesn't share either one of these legs to that right angle, so that's the hypotenuse. It's opposite. Okay? On a right triangle it is, but just because you have a triangle and you have a longest side doesn't necessarily mean it's the hypotenuse. Because what if I had an obtuse Oops, come on, grab it. What if I had an obtuse triangle? This is the longest side, but is that the hypotenuse? It's the longest side of the triangle. Is it the hypotenuse? Why not, Jake? It's not a 90-degree angle there. That's right. Okay, there's not a 90-degree angle, so I cannot call that the hypotenuse, even though it's the longest side. I don't call it anything. I just call it one of the legs of the triangle, or one of the sides, I should say, of the triangle. Not calling it anything. All right? Quit trying to be silly. It's not even funny. So anyway, let's continue with this. So the sine is the opposite over the hypotenuse. Okay, let's do cosine. What's cosine equal to? It's equal to the adjacent. I'll just write it like that. Adjacent over hypotenuse. And then the last one is the tangent, and it's opposite over adjacent. Now, oops, that's an A. How we learn a quick little easy way to remember these things. Okay, you could sit here and just memorize them, but there's a nice little, they call it a mnemonic device. The word doesn't really mean anything itself, but it stands for something. Say it. How do you spell the so? S-O-H, and then the ka is C-A-H, and then the toa, T-O-A. All right, so watch. Yes, I did remember. Look at this. Sohcahtoa. It really doesn't mean anything, but it just kind of sounds cool, kind of rolls off the tongue a little bit. Actually, when I was in high school, my teacher taught us Toa Soka. That's how I always remembered it, Toa Soka. But when I started teaching, a lot of kids coming up, their math teachers always taught them Sohcahtoa, so I teach Sohcahtoa, even though I used to say Toa Soka all the time. Really doesn't make any difference, does it? No. All right, as long as it's so, and then a ka, and then a toa, it doesn't matter what order you put it in. But look, what does this mean? The sine is what? Opposite over hypotenuse. That's what it means. Even though it's not actually over it, it's just an easy way to remember it. See it? The cosine is what? Adjacent over hypotenuse. Then the tangent is opposite over adjacent. So if you can remember this, you can remember the different ratios of our trig functions. Remember, the sine is not a variable. It's not like an x or an a or something like that. It's just a word. I actually looked it up in one of my other classes. It's a word that it comes from the Latin, and I even forget exactly what it means. You can look it up. I just Googled it and put, what does sine mean or something like that? S-I-N-E. What does sine mean? And then I found a response, and it says from the Latin word whatever, whatever, and it means whatever. Okay, that's how much of an impression it made on me. But anyway, it comes from the Latin. I do remember that. The cosine is actually, I think they said it's the complement of the sine. All right, I kind of understand that. You might not completely understand that, but that's fine. It means the complement of the sine. Tangent, it's actually from a Latin word again that means to touch. In the chapter that we're on right now, we're talking about circles, and we're talking about a line touching a circle at one point. That's called the tangent of the line. I'm not really sure how this tangent comes into play as far as touching the line, but these words do come from the Latin. That's all. You probably don't even care about that much, but that's okay. Let's do this. Let's do an example on why in the world do we need to know that stuff. Well, the whole reason that we learn this stuff is to solve for missing sides and solve for missing angles. You know how I called that other one angle A? Yeah. Now look, don't flip out when I do this, but I'm going to put another letter in here. But it's a letter that's not even a letter in our alphabet. It's not one of our 26. Okay, it's actually in the Greek alphabet. It's a Greek letter. But look, you've dealt with Greek numbers before, or Greek letters, I should say, before. What's a real famous Greek letter that you use a lot? It actually stands for a number.
0.
It stands for a certain number. Nope. I don't think I heard it yet. It's a no.
Omega.
Sigma.
Pi.
It's pi. Pi.
What? How's that stand for 0?
It doesn't. I never said it stood for 0. I said it stood for a number. I never said it stood for 0. It stands for a number, which is what? 3.14159, whatever. Okay, and it keeps on going. You guys listening? You guys are having your own little conversation. Let's pay attention up here. So pi is a Greek letter of the alphabet, so we use it. We don't have that much of a problem with it. In trig and in geometry and stuff like that, when you have an unknown angle and you're trying to find an angle, a lot of times, not all the time, but a lot of times, they'll use this letter right here. It's kind of like a 0 or an O with a little swoosh thing through it. Okay, kind of like the Orioles O. All right, that's how I draw it anyway. Different books draw it a little bit differently, but we call this Theta. Theta. You ever see those sweatshirts that like fraternity and sorority people wear and stuff? They got all these Greek letters in there. You'll see theta is one of those letters, okay? So this letter right here is a theta. We use it because we just stands for an unknown angle. It's kind of a universal thing. You'll see that as you go on further in your math career. If you do a lot of math in the future, you're going to learn a ton of different Greek letters. You almost know the whole Greek alphabet by the time you finish math, okay? Not quite, but there's a lot of letters that stand for certain things. Theta stands for an unknown angle, and we use that quite a bit. Sometimes people use different Greek letters, but that's probably the most popular one, okay? It's theta, not theta, not theta. It's theta. It sounds like an A. Everybody got it? Good. All right, what I'm going to do is this. Let's put some numbers in here. Let's say, we'll make it really easy. We'll say that side's 3, this side's 4, and we'll say that side's 5. Okay, let's set up our trig ratios, and I'm going to show you how we can actually solve for that angle by knowing these sides right here. In fact, I don't even have to know all 3 sides. All I got to know are 2 sides, and I can actually find what that angle is equal to, which is kind of interesting. So let's set up some ratios first, like we were doing up here, right? We did this opposite over hypotenuse, all that kind of stuff. Let's do it though. Let's do it with some numbers. All right. So let's do the sine. Now watch. We always take the sine of the angle. So what's the angle that I'm working with right here? It's theta, right? Okay. So let's take the sine of theta and find out what the sine of theta is equal to. Well, do you remember? Let's write it down. Sohcahtoa. Let's write that down. That might help you out a little bit. Okay. After a while, you'll have it memorized. You don't even have to write it down. But you're learning this for basically the first time, so write it down. So the sine is the what? The opposite over the hypotenuse. Opposite over hypotenuse. So here's the angle right here. What's opposite this angle theta? 3. So that's opposite over the hypotenuse. What's the hypotenuse? That's it. Okay, that's the sine of theta. Now we're going to actually use this. I'm going to show you in a couple minutes how we can actually solve for theta with this little, I shouldn't say formula, but this little equation right here. Okay, I'm going to do all 3 of them just so we recognize how to do this. So I'm going to take the cosine of the angle. Never take the cosine of one of the sides. It doesn't make any sense. You're always taking the cosine of the angle, because what you're saying is, okay, if I take the cosine of the angle, that word cosine means I'm going to take the ratio of the adjacent side to that angle over the hypotenuse. You get that? So that's what it means. It's not a variable. You can't divide by the cosine. You can't multiply by the cosine. But you can take the cosine of an angle. So the cosine of the angle is what? It's the adjacent over the hypotenuse. So which one's the adjacent to angle theta? 4 over the hypotenuse again, which is 5. All right, let's do the tangent. The tangent of theta is equal to what? The opposite over the adjacent. Which one's opposite? And which one's adjacent? They're all 3 different ratios, aren't they? So that's what these words represent. Instead of me sitting here and say, okay, take the ratio, take angle theta, and take the ratio of the opposite side to the hypotenuse. That'd be kind of lengthy, wouldn't it? Instead of saying all that stuff, all I got to do is say, hey, take the sine of theta. That automatically tells you something. It automatically tells you that you're going to take the opposite side over the hypotenuse without me actually having to say that. Does that make sense? Okay, that's what those words represent. Okay, now there are some questions in the worksheet that I'm going to give you and things like that where all they're going to say is find the sine or the cosine or the tangent of a particular angle. And they're going to say write it as a fraction and write it as a decimal. I just want you to write it as a fraction. You hear what I said? The question's going to say write it as a fraction and a decimal. Forget the decimal. Just write it what? As a fraction. So if it said find the sine of theta, what's your answer? 3 over 5. That's it. Everybody got that? If it said find the cosine of theta, what's your answer? 4 over 5. Tangent of theta, 3 over 4. Everybody got it? Okay. All right. So now, what everybody's been waiting for. We're going to, drum roll please, we're going to actually solve for theta. We're going to find what this angle is actually equal to. All right, you guys watching? Actually, it was rhetorical. Okay, thank you for the drum roll. Now watch this. What I want to do is I want to actually solve for theta. I got to do a little bit of background. Hang with me for a second, okay, why we do this, because I think it's important that we do this. You probably didn't learn this in Algebra 1, but in Algebra 2 you're going to learn something. This is kind of like getting you ahead of the game a little bit for next year. Talking about how to find the inverse of something. So watch, if I had a 4, and if I want to find the inverse of 4, or the reciprocal, it's kind of the same thing. What would be the reciprocal of 4?
1 over 4.
1 over 4, okay? But watch this. What we do in algebra, I'm not going to go through a lot of detail on this, but in algebra, to find the inverse of something, this is what we do. We take it to the negative first power. All right? You probably never worked with negative exponents before. In algebra 2, they start talking about that. If I have 4 to the negative first, what it's doing is taking the inverse of it. Okay? So 4 to the negative first is the same thing as 1 over 4. So I'm just looking at this right here. That symbol, taking something to the negative first, means you're taking the inverse of it. Okay? So look at this. I want to get theta by itself, so I have to get rid of the sign. Well, I can't divide by a sign. We just talked about it a few minutes ago. You can't multiply by a sign or divide by a sign. The sign itself is not a number. You hear me? The sign is not a number. I can't just divide by this like it was an X or an A or a B or something. But I can take the inverse of it. So watch what happens. If I take the inverse of the sign, it actually cancels out. But in algebra, if I take the inverse on one side, what do I have to do to the other side? I got to do the same thing. So I'm going to take the inverse of the sign of the other side. How do we show inverse? We show it with a -1 as an exponent. So watch what I'm going to do. I'm going to put a sign and do what? To the negative first of 3/5. That might look kind of weird, but I'm doing that for a reason, because on your calculator you're going to see exactly this. All right? And I want you to understand why we're doing it. So all this stuff right here, don't worry about all the details of it, but just understand that when I show the inverse of something, I take it to the negative first power. So theta is equal to the inverse sign. Do you see that? Inverse sign, because that little to the negative first means inverse. The inverse sign of 3 divided by 5. So how does that work on the calculator? Well, I'm glad you asked that question. I know you don't. That's okay. I'll show you how to do it on another calculator. But I'm going to show you on this one because I just happen to have this one. If I hit sign to the negative first, look on here. Look at, there's the regular sign right there. You see it? But what's in yellow right behind it? Sign to the negative first, isn't it? That's the inverse sign. How do I get to that? How do I get to that second function? That's right. So look what I'm going to do. If you have this calculator, this is what you would do. You would hit second function and then hit the sign. See what it did? It made sign to the negative first. Do you understand why I wanted to show you that now? Because you'll see it on this calculator. So sign to the negative first of what? They even give you one parentheses. Put 3 divided by 5. 3 divided by 5. Close the parentheses. And watch, as soon as I hit enter, guess what it's going to give me? It's going to give me theta. It's going to give me the angle. I'm going to actually solve for that angle in that triangle. So watch what I do. I hit enter. There it is right there. That's my angle. 30. Let's round it to just the nearest degree. What would that be to the nearest degree? 37. Okay? I'll answer questions in a second. Let me finish. I still got a couple of things I want to talk about. So that angle right there is angle 37 degrees. Well, that's kind of cool, isn't it? So we would have never been able to find that before because you didn't know this other angle. Now you know this is 37 degrees. How could you find this angle up here? Yeah, well, you could do it another way, but look, if I know this is right and I know this angle, what's a real easy way? Just take it from 90, right? What's 90 minus 37? It's 53, right? It's 53 degrees. So I could find both of those angles now, right? One, I had to do the trig function. Once I find one angle, I could find the other one very easily just by taking it away from 90. Now, I'm going to do this 2 more times just to show you that you could use, if you know all 3 sides of the triangle, right? I knew 3, 4, and 5, didn't I? You could actually do the same thing and find the same exact answer 3 different ways. All right? Now, you don't have to do it 3 different ways, but I'm just showing you, all right, just because I think it's kind of cool. I think it's kind of cool that all 3 of these, theta should be the same thing. So let's do it. So if I wanted to solve for theta, I would take the what? Not the inverse sine this time, but what? Cosine. The inverse cosine. So I put cosine to the negative first of 4 over 5. And now I can put this into a calculator. Remind me to show you how to do it on the other calculator as well. Okay, so watch what I do here. What do? Second function, cosine this time, right? So it's cosine to the negative first of 4 over 5. 4 divided by 5, parentheses, hit enter, and bang, look at that.
That's impossible. So all
Same exact thing. I told you it'd be the same thing, didn't I? All right, isn't that cool? So it's 37 degrees. Go ahead. Play.
Does that mean that, hold on, this is the same way to solve for one angle?
I'm just showing you 3 different ways to solve for the same angle. Okay? Remember I told you at the beginning? I said I'm going to get all 3 of the same answers? Right? It's just different ways. That's all it is. So look at this. Let's do this one. It's kind of fun, isn't it? So what do I do here? How do we get rid of the tangent? Take the what of it? Take the inverse of it. So we got to take the inverse of the other side as well, don't we? So 3/4. Now watch this. They're different fractions and different trig functions, but watch this. Second function what? Tangent, right. Second function tangent. That to the negative first means you take the second function of what? 3 divided by 4. And then watch this. What should it be?
36.8.
That's right. Look at that. Exactly the same thing. Isn't that cool? I like that. So what? Theta is, if we round it, 37 degrees. Look, I found this angle 3 different ways. Got it? All right, that's pretty cool. But what if we had this? What if I didn't know what that was? Now you know what it is. I understand that. You just saw it 2 seconds ago, right? But let's just pretend. Let's just pretend you didn't know what this side was, okay? That's right. You just use tangent because I don't know what this side is, so I can't use sine, right? I can't use cosine because it's got hypotenuse and I don't know, right? Air quotes. I don't know what this side is. So all I know is what? Opposite and adjacent. So I use the tangent. What if I had this? What if I only knew this information right here? What would I use? It's not ka. It's how you remember which one you use, but we don't say we use ka. It's the cosine. Why is it the cosine? Because it's adjacent over hypotenuse. You see it? So I would use the cosine. Okay. What if I knew this side right here and I didn't know this one? Then what would I use? Use the sine. Because look, I'd use the opposite over the hypotenuse. Everybody seeing that? I hope. All right. Tell you what. Let's do this. I don't want to beat this into the ground too much, but I think it'd be good. Now we knew this was 37, right? If this is 3, 4, and 5, and this is what? 53? So let's just do this. Let's say this is 53 degrees. Let's pretend. Actually, I lied. Let's say we don't know this angle at all. Okay? Now, I'm not going to call it theta because I called that one down there theta. Let's call it, now you could call it beta. All right, we'll just say B instead of beta. There are teachers that teach it that way. If you look at Con and you look at his trig stuff, he uses alpha and beta. To me, might as well just use A and B, right? So that's what we're going to do. We'll call this angle B. Now watch very carefully. Let's just do one of these. I'm not going to do all 3 versions. In fact, let's do this. Let's say we don't know what that is. All right? Let's just pretend we don't know what that is. We only know these 2 sides right here. How would you solve for angle B? Well, what 2 sides do we know? What is 4 to angle B? It's opposite. What is 3 to angle B? It's adjacent. So I've got opposite, I've got adjacent. Which trig function uses opposite and adjacent? It's TOA, tangent. That's right. It's tangent. So I take the tangent of what angle? What angle am I talking about here? B, this one up here. So the tangent of angle B is equal to what? Opposite over adjacent. Which one's opposite? 4 over 3. Everybody see that? Now watch. Plug that in my calculator. Actually, I got to solve for B first. Let's do that. Solve for B. How do I get rid of that tangent? Take the, give me the word. I want to hear the word. Take the inverse. Right. Take the inverse tangent. So B is equal to the inverse tangent of 4 over 3. We've done this like 4 times now. You should be catching on a little bit now, right? So now let's figure out what we get. So turn it on. Let's take the, let's clear it. Let's go second function tangent. Watch. Second function tangent, right? That's inverse tangent of what? 4 divided by 3. Let's see what we get. What should we get? What do you think we're going to get?
37.
Nah, what was this
Oh,
angle?
53.
We'll probably get 53, right? Let's cross our fingers. Ready? Boom. Look at that. We do. All
No, that's 53.1.
right, you're being silly again. So that's, if we round it to the nearest degree, it's 53 degrees. All right? Just like we thought it should be, right? Isn't that cool? So you don't have to just use this angle. You could use this angle up here, right? Now, on this situation, if I don't know what the hypotenuse is, can I use the sine? Dave? No, I can't because the sine has hypotenuse in it, right? And I don't know the hypotenuse. Could I use cosine of this angle? No, because I don't know what the hypotenuse is either. But if I don't know the hypotenuse, I can always go opposite over adjacent. You good?
My camera's not working.
It's not. Now we're going to do something a little bit different. It's kind of the same, but watch. This time I actually know what this angle is. Well, it's a right triangle. I need to know that first of all. But I know this angle right here. Let's make up one. Let's say 3 degrees. Let's say it's 23 degrees, okay? And let's say I don't know that, and I don't know this, but I know this. Let's make this, 10. Is that all right? So what I'm going to be able to do now, I can actually use my trig functions to solve for x and to solve for y. It's a little different though this time. It's just a little bit different. We're not going to do any inverse stuff. The only time, and I told my other class this, you should write this down as well. The only time you use this, where did I do this? Anytime you use this inverse stuff, right? Inverse, 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 is when you are finding what? The angle. Okay? That's the only time you use the inverse. If you're finding one of the lengths of the sides, then you're just going to use regular sine, cosine, tangent. You're not going to hit the second function. Do you hear what I said?
Yeah.
All right. Write that down somewhere, okay? You only use the inverse. Okay? You only use the inverse when you're finding the angle. Okay? When you find the sides, you're just using straight up sine, cosine, or tangent. You'll see that right here. All right, I've been using this white all the time. Let's go to another color. I'm getting tired of that. Okay. Now look at this. Let's say I wanted to solve for x first. All right, solve for x. I know an angle this time, don't I? It's not an unknown angle, so I know my angle. I don't know this. What is this length compared? What is this side compared to this angle in relation to it? It's what? It's opposite. And what side? What length do we actually know? We know the hypotenuse. So I've got opposite and I've got hypotenuse. Which trig function am I going to use with opposite and hypotenuse? Use the sine. That's right, because it's OH. If you need to, watch. Write OH. Which one goes with the OH? The S. It's the so, right? Sine. Everybody see that? So I've got opposite, hypotenuse, OH. That's sine. We good? So let's come down here and let's figure out how to use it. This is actually kind of easy. So I take the sine. Now I don't take the sine of theta, but I do take the sine of the angle. What's the angle? It's 23. Everybody see that? Someone in the other class said take the sine of x. No, you can't take the sine of x. You can't take the sine or the cosine or the tangent of one of the lengths of the sides. You can only take it of the angle. So it's the sine of the angle equals what over what? Opposite over hypotenuse, or x over 10. That's right. Now look what we're going to do. We're going to do a little bit of algebra. When I say a little, I mean a little, not much at all. I want to solve for x, don't I? How do I get rid of the 10 then? I multiply it. It's being divided, right? You always do the opposite. It's being divided. How do I get rid of something that's being divided? I multiply, right? That way they cancel out. Multiply this side by 10, but then I also have to do what? Multiply that side by 10. You okay with that? So watch, that cancels with that. There's x, it's by itself, isn't it? And then all you got to do is plug in 10 sine of 23. Man, I keep forgetting to show you how to, you haven't been reminding me. So I want to show you how to do it on your regular calculator. Okay, let's do this on this calculator, then I'll show you how to do it on a other. When I say regular, I mean like a TI-30, yeah, like that, okay? So watch. On this one, what are you going to do? You're going to put it in exactly the way it looks right here. Just put 10, and then what else do you think? Sine, not second function, right? We're not taking the inverse, we're just taking the sine of the angle. The sine of what? 23. Everybody see that? Plug that in, and I get 3.9. That's how long that side is right there. It's 3.9. All right, let's take a look at it. That's 3.9 right there. And that's how you find one of the lengths of the sides. It's kind of cool. Now look, if you wanted to, you know two sides of this right triangle. If you wanted to, I guess you could use Pythagorean theorem to solve for the other one, right? Because you know two sides. But we're trying to learn trig functions, so let's not use Pythagorean theorem. When I finish this, I promise I'll show you how to do this in the other calculator. Okay, but let's finish this one up. Let's solve for y. Here's what we're trying to solve for right there. Let's pretend we didn't know this. Pretend we don't know that's 3.9, okay? So I want to solve for y. Trying to find y. What is y to this angle right here? It's the side that's adjacent to it. Now what side do we know? 10, which is the hypotenuse. So I have adjacent and hypotenuse. Right. It's cosine, isn't it? All right. C-A-H. Cosine. So I'm going to use the cosine of this angle. So here I go. Cosine 23 degrees equals what? Adjacent over hypotenuse. Which one's adjacent to this? Over hypotenuse, which is 10. Look, the math is exactly the same, isn't it? So how do we get rid of the 10? Multiply by 10. Multiply this side by 10, right? And then y equals 10 times the cosine of 23. It's just a matter of putting that into a calculator. So let's see what we get. We get 10 instead of the sine of 23. Now it's the what? The cosine of 23. Put that in there, 9.2. So y is approximately, it's not exactly, but it's approximately 9.2. And there you go. So you've got all the sides of that triangle now. You got that side, you've got that side. Look, do those numbers make sense? We said this was 3.9. Well, if this is 23 degrees, what's this angle up here going to be? 67? 60, right? Yeah, it's 67. All right, because that's 10, carry the 1, 8 and 1's 9. Okay, so watch. Which one's the smallest angle? 23, right? Look at the side opposite the smallest angle. Is that the smallest side? Yep. 67. Is y the medium side? Yep. And is the hypotenuse the longest? Yes, it is. Okay? It's a good check, isn't it? It's a good way to check to make sure that you're doing this right. Because if you got the side opposite to 23 being bigger than this side right here, you know you did something wrong. So don't just trust your calculator. Your calculator will not let you down because it'll always give you the right answer to what you punch in. But sometimes you might punch in the wrong thing. Make sense? All right. Let me show you how to use your calculator. Now, I don't have one of those calculators to use on the screen right here. But let's say we're doing, let's do the inverse one first. So what do? We said like theta is the inverse sine of, I don't know what, 3 over 5. Let's just do that. This is how you would do this on a TI 30. I think it's XA. Is that what your calculator says? Okay. A lot of people have these. It's real inexpensive. You can go to Walmart or Kmart and get it for like 10 bucks. Okay? It's really inexpensive calculator. So this is what you would do. First of all, you would hit 3. All right? If you have that calculator, follow my steps. Hit 3 first, and then divide, and then 5, and then equals. You'll probably get 0.6, won't you? All right, so 0.6 shows up on your calculator. Now what you're going to do is you're going to take the inverse sine of that. So you put the number in first, then you take the inverse sine. It's opposite of the graphing calculator. The graphing calculator, you hit inverse sine first, right? Then you put 3 over 5. It's kind of backwards. So you go 3 over 5 first, get an answer, hit equals, get an answer. Then you take the second function. Does yours say second or the yellow? Okay, and then second function what? Sine. And then that should give you your answer. You shouldn't even have to put in the equal sign. And what was that, by the way? So around 37? Okay, 37 degrees. 36 point something. Did you get that? So that's the steps that you do on a regular scientific calculator. All right? Does somebody have a calculator with the readout is kind of like a little wider, like 2 lines of stuff? Does anybody have a calculator that looks like that? So does everybody either have a graphing or, Joe, show your calculator. Does everybody have a calculator like that or a graphing? Does anybody have a different calculator than that? No? All right, because a couple people in the other class had different calculators. But that's how you do it. How would you do the one we just finished doing? what was it, like x equals, what did we say it was? 10 sine of 23. Let's do this. 10 sine of 23. How would you do this in a TI 30XA? You do it a couple ways, but I'm going to show you one way. I like doing it like this. First of all, I like to figure out what that is first, then multiply it by 10. So we don't hit sine first on a TI 30. All right? You hit 23 first. Okay? So put in 23, then hit, what do you think? Sine. That'll give you some decimal number, won't it?
Yeah.
Okay? And then you take that number, and what do you think? Times what? 10. All right? So that's the order that you do that on a TI 30. So hit 23 sine. That'll give you the sine of 23. And then you multiply it by 10, and it should give you the same exact answer as we got earlier. Make sense? Okay. So, I mean, to tell you the truth, I use this calculator more than I ever use a graphing calculator when I'm doing this trig stuff. So I'm really, really used to doing it kind of backwards, right? You put the number first, and then you put in what the function is. Okay? On a graphing calculator, you do the function first, then you put the number in. All right? It's just a matter of preference, I guess. All right. Enough of that. Let me give you a worksheet. I'll let you work on that.